Viewers, in the previous lesson, we learned how to construct network without the durations, or rather the time estimates. Today, I want to tell you how to draw network using the time estimates. Now, in construction of network using time estimates, there are two techniques. One is known as critical path method or technique. The first one is known as critical path method. Then the other one, number two, is known as project or programmable project evaluation and review technique, which is also known as PART, project evaluation and review technique. Those are the two methods which are used when we construct network using the duration. Let us start with the first one, critical path method. This is the construction of network using known time estimates. So the estimates for each duration are given, and we don't calculate them. We use them the way they are given. So in construction of network using the critical path method, each node is now subdivided into three. And this is applicable generally to construction of network with the time estimates, with any time estimate. So each node is subdivided into three parts. The first part is now called the event. This is the event. We are going to indicate the event when we construct. This one is known as earliest time. Then this lower one is known as latest time. So each node is going to be subdivided into three parts. This one we are going to now factor in the numbering of the events. This is earliest time, earliest time. This is latest time. Now I want to tell you how to estimate earliest time in a network. In estimation of the earliest time in a network, you add each activity duration from left to right, as I will show you when we take an example. We add each activity from left to right and pick on the maximum duration till you reach the last event in the project. On reaching the last event in the project, we conclude that the earliest time is equal to the latest time for that last event in the project. This process of adding each activity duration from left to right and picking on the maximum duration is known as forward pass. Then how to estimate the latest time? In estimation of the latest time, we subtract each activity duration from right to left backwards and pick on the minimum duration. We pick on the minimum duration. till we reach the first event in the project. That is normally known as backward pass. So that is how to estimate the latest time. That is backward pass. Then after estimating the two time estimates, that is the earliest time and the latest time, we can now determine the critical path. And the following is how to determine the critical path in a network. One, critical path is the longest path and contains activities and events which determine the total project duration. Then critical path, number two, critical path, this is the path whereby the earliest time must be equal to the latest time for any activity that falls along that path. So after that, we can even determine the float for non-critical activities. Float is only calculated after you have determined the critical path. And float is defined as the spare time taken by or calculated on the activities which do not exist along the critical path. That is what is known as float. In fact, under normal circumstances, there are three types of floats. Namely, there are these types of floats. The types of floats are: one, free float; two, total float; and number three is known as independent float. These are the three types of floats which are mostly found. They are the ones which are mostly found in project planning. Let me tell you how to calculate this free float. Now, because I had said free float is this is only calculated like any other float on activities which do not exist along the critical path. Those are the activities we have their spare time in project management or project planning. So free float is equal to, this is the formula for calculating free float: earliest finishing time minus earliest starting time minus the activity duration. EFT, this is earliest finishing time for that activity minus earliest starting time for that activity minus the activity duration, which is represented by D. That is for free float. Then for total float is latest finishing time for an activity minus earliest starting time for that activity minus the activity duration. Total float is equal to latest finishing time for the activity minus earliest starting time for that activity minus the activity duration. Then independent float is equal to earliest finishing time for the activity minus latest starting time for that activity minus, that is starting time for that activity minus the activity duration. These are the floats and how to calculate them. So independent float is EFT. This is to help the learners to memorize EFT, that is earliest finishing time minus latest starting time minus the activity duration. Then let me now start whatever I've explained. I want to get an example and draw the network with the help of the duration and eventually determine the critical path and also calculate the floats. So let us take this example. Let us say this is example 5 based on the previous lesson. So this one, let it take example 5. Now our project comprises of the following activities whose durations are in days. So activity A preceding activity is none, duration is 2, and so on. Then the question is draw network diagram, determine the critical path, and determine the total float, free float, and independent float for non-critical activities. And this is how this network is supposed to be drawn. Activity A is the first to occur in this project. Activity A is the first to occur. So we are going to draw it like this. That is activity A. Then activity A is a preceding activity to activity B. Activity A is a preceding activity to activity C. Activity A is a preceding activity to activity D. So this means A is giving rise to B, C, and D. B, C, and D. So we draw like this. This is B, C, and D, following that pattern. Then B gives rise to B is a preceding activity to activity E. So from B, that node, we get E. Then C is a preceding activity to activity F. But we are told here we can see E and F are converging. So C gives rise to F, which goes all the way to meet with E. So that is C is giving rise to F. So that is F, and that is E and F converge, both of them converge to give rise to I. This is I here. We draw its node. Then that is E and F come up here. C is a preceding activity to activity G. C is a preceding, this is C here. C is a preceding activity to activity G. So its node is here. That is G. Then C and D are converging to give rise to H. C and D are occurring at the same time. B, C, D are occurring at the same time and originating from this node. So C and D, again, we are told that they converge, and those activities which occur at the same time will only converge when you indicate in a network by using dotted arrows. And that is, these activities are known as dummy activities. They occur at the same time or simultaneously. They do not consume time or resources. So their duration will be 0. So this is, draw here. So C and D are converging to give rise to H, but H is converging with G. So H moves from there, H moves from there, H moves from here. This is H. H to give rise to G and H now. G and H, both of them will converge to give rise to J. And J and I are converging. So you draw that line, that arrow is going that side to converge with I. And that is what? That is J. Then I and J are converging to give rise to K. To give rise to K, we give space here, to give rise to K. So from there, I and J give rise to K. This is K is here. Then that is the last node in that network. That is the last node in the network. That is the last node. So that is the network, but we are not yet through, because we must take into consideration the duration. And earlier, some minutes ago, I had said that when you construct network using time estimate, you must subdivide each node into 3 parts. So at this point in time, we must now subdivide each node into 3 parts to accommodate the events, earliest time and the latest time. So we start from here. So start by numbering the events. That is 1, 2, this can be 3, this can be 4, 5, this can be 6, 7, or this can be 6, 7, 8, 9. That is the what? The events. Then we now bring into the network the duration. The duration were in days. So activity A takes 2 days according to the information given. Activity B takes 3 days. Activity C takes 5 days. Activity D takes 8 days. Activity E takes 6 days. Activity F takes 1 day. Activity G takes 2 days. Activity H takes 3 days. Activity I takes 7 days. Activity J takes 4 days. And lastly, activity K, which takes 5 days. We want to start by estimating the earliest time. Once more, I'd said how to estimate the earliest time is we add each activity duration from left to right and pick on the maximum duration. 0 plus 2 is 2. That is, A will be completed after 2 days or the second day. Then 2 plus 3, because duration for B is 3. 2 plus 3 is 5. Then C takes 5 days, but is only started after the completion of A in the second day. So that is 2 plus 5, that is 7. Then D, 2 plus 8 is 10. But we said dummy activities, their duration is 0. 7 plus 0 is 7. The maximum duration we take now is 10, because this is 2 plus 8. We write here 10. Here we are faced by 2 paths, E and F. We are going to consider whatever happens in each path. add and pick on the maximum duration. So that is 5 plus 6, 11. Then 7 plus 1 is 8. Obviously, maximum is 11. Then we are here, which we are also faced by two parts. 7 plus 2 is 9. And 10 plus 3 is what? 13. Maximum is 13. We take maximum. Then we are also faced by two parts here. 11 plus 7 is 18. 13 plus 4 is 17. And therefore, 18 is the maximum. Then 18 plus 5 is 23. So immediately you reach the last event here. Its earliest time is equal to the latest time. There is no any other event coming after this. That is how to estimate the earliest time, which I had said is also known as forward pass. We come to backward pass by filling in the blank spaces. That is, we want to estimate the latest time. In estimation of the latest time, I had said we subtract each activity duration from right to left backwards and pick on the minimum duration. 23 minus 5 is 18. We are here. 18 minus 7 is, that is 18 minus 7 is what? Is 11. (18 minus 7 is 11). Then 6, that is 11. Then 18 minus 4, that is what? That is 14. We are here. 14 minus 3, that is 11. Now here we are faced by three parts. This one, and this. So 11 minus 1 is 10. Then 14 minus 2 is 12. Then 11 minus 0, because this is 0, that is 11. Minimum is what? Is 10. So we pick the minimum. We are here. 11 minus 6 is 5. Now we are left with this node. So we are going to consider what happens in each path. There are three paths here. And we'll subtract and pick on the minimum duration. 5 minus 3 is 2. 10 minus 5, that is 5. Then 11 minus 8, that is 3. The minimum is 2. Now, critical path is the longest path in a network. It consumes more time and resources. Along the critical path, earliest time must be equal to the latest time for any activity that falls along that path. So let us check. From here you can have various longest paths, but the other ones will be dropped on the condition that with critical path, the earliest time must be equal to the latest time for any activity that falls along that path. So this one is 2, 2, 5, 5, 11, 11. 11 is equal to 11, 18 is equal to 18, 23 is equal to 23. So we cannot take this path because its earliest time, 7, is not equal to 10. Then 10 is not equal to 11, 13 is not equal to 14. So let me highlight the critical path. The critical path is now earliest time is equal to the latest time 2, 2, then 5, 5, then 11, 11, then 18, 18, then 23, 23. That is the highlighted critical path. Then what we do now is we can now write critical path of that project is A, B, these are the activities which represent the critical path, E, I, and K. Then the duration of this project, duration is here, 23, because they were in days. The duration in days, 23 days. That is the critical path. So that is the network which is drawn with the help of the time or duration. Now, we want to calculate, I want to show you how to calculate the floats. We wrap this now. Let me tell you how to calculate the floats. Now, once more, float is calculated on non-critical activities because this is spare time. We cannot calculate floats on the critical path activities. These are very crucial and critical such that there is no spare time which is put for these activities. So for us to calculate the floats, we must identify those activities which are not existing along the critical path. So let us first of all list those activities whose floats can be calculated. And they must not be among these critical path activities. Start with total float or total float because there are many activities. I hope so. Total float. Then we have free float. Free float. Then we have what is known as the independent. Independent. We have independent float. We have independent float. Then so we have now to identify the activities which are not existing along the critical path. The first one is C. The second one is D, F, C, D, F, G, H, and J. So that is C, D, F, G, H, and J. The rest are activities which are existing along the critical path. So C, D, F, G, H, and J, we want to these are the activities whose floats we are going to calculate. Now, for us to calculate the total floats, there must have been a formula. In fact, I'd given a formula out. Let me again write them. Total float, we said it is calculated as latest finishing time for activity minus earliest starting time for that activity minus the activity duration. Then a free float, that is equal to or is equal to, free float is equal to earliest finishing time minus earliest starting time minus the activity duration. EFT minus EST minus D. Now, independent float is equal to earliest finishing time minus latest starting time minus the activity duration. Those are how to calculate them. That is the floats. Let me start with C, and I want to start with calculation of the total float. So total float. So total float for activity C. Activity C, it is started at duration 2 days after the completion of A. So earliest starting time is 2, and latest starting time is also 2, and that one is because they are the same, because they are overlapping along the critical path. So then C, earliest finishing time, if everything goes on well in that project, C can be completed in the 7th day or after 7 days. Then if things delay the completion of activity C in that project, it can be completed on the 10th day. So earliest finishing time is 7, latest finishing time is 10. So latest finishing time for activity C is 10 minus 2, which is earliest starting time, minus its duration, which is 5. 10 minus 2 minus 5, that is giving what? 3. And these are in days, 3 days. So we go to D. D is, we are still on total float. Latest finishing time for D is 11, minus earliest starting time for D is 2. Then duration for D is 8, and that is 1 day. Then F is 11 minus the earliest starting time for F is 7. Earliest starting time is 7. Then minus 1. That is 11 minus 8, which is 3 days. So we are on G. G, the latest finishing time is 14. latest finishing time is 14 minus earliest starting time is 7, then minus the duration, which is 14 minus 9, which is 5. Then H is 14, H is 14 minus earliest is 10 minus 3, and that is 1 day. Then J is 18 minus the earliest starting time is 13 minus 4, which is what? 1. That is 18 minus 17, which is 1 day. These are the total floats for those activities which are not existing along the critical path. Let me now calculate the free float for non-critical activities. Free float, we start with the C. Free float, earliest finishing time for C. Earliest finishing time for C is 7 minus earliest starting time, which is 2, minus the duration, and that gives us 0. 7 minus 2 minus 5, which is 7 minus 7, which is 0. Then D is earliest finishing time for D is 10 minus 2 minus 8, which is what? 0. For F is 11 minus earliest starting time is what? Minus 7 minus 1. 11 minus 7 minus 1, that is for F. 11 minus 7 minus 1, which is 11 minus 8, which is what? 3. Then G is earliest finishing time for G is 13 minus earliest starting time for G. Earliest starting time for G is 7 minus the duration. So that is 13 minus 7, which is the earliest starting time, then minus 2. So 13 minus 9, which is what? 4. 13 minus 9, which is 4. Then H is 13, that is earliest finishing time, minus earliest starting time, minus the duration, that is what? 0. Then the J is 18 minus earliest starting time, which is 13 minus 4, which is 1. That is the duration, that is the free float for J. Then let me go to independent float. So independent float, that is for C, earliest finishing time for C is 7 minus latest starting time is 2 minus the activity duration, which is what? 0. So activity D. Activity D is earliest finishing time. Activity D earliest finishing time is 10 minus latest starting time minus 8, that is what? 0. Then for F is earliest finishing time is 11 minus latest starting time for F is 10. Then minus 1, which is the duration. So that gives what? 0. Then for G is earliest finishing time for G is 13 minus latest starting time for G is 10 minus 2, which is the duration. So that gives us 1. Then for H is here. The earliest finishing time is 13 minus latest starting time is 11 minus the duration, which is duration is 3. That is 13 minus 14, which is -1. Then this -1 is having an implication in the sense that that activity was delayed by 1 full day. So the succeeding activities, the activities which are to occur after that will be delayed by 1 full day when you are performing the activities which were supposed to be done on the previous day. So let us move to J. J is 18, that is 18 minus, that is latest finishing time is 14 for activity J, minus 4, which is 0. That is on the independent float for activity J. These are how to calculate the floats, and therefore that question is complete. It's completely answered. Now, viewers, we want now move to the next. This is the critical path. I'd said that there are 2 methods which are used in the construction of network when durations are given. One is the critical path method, where you are told activity A takes 2 days, activity B takes 3 days, and so on. We want to move to another method of constructing network, and that method is known as project evaluation. That is the second method, project evaluation and review technique. That is PERT.